This lesson deals with supplemental problem 4.9. You can find this problem in the ECE302 ebook in the Chapter 4 Supplemental Problems on page 16. Given this p-channel JFET circuit, where I sub SDS is 2 milliamps and the pinch-off is -2, and 3 resistors and a power supply, given the power supply, could you pick the 3 resistors such that the drain current is 1 milliamp and that the source to drain voltage is 10 volts and the current through the resistor R1 and R2 is 100 microamps? Well, let's label on our drawing the things that we know, saying that this is 10 volts and this is 1 milliamp. And here's my gate, and here's my source, and here's my drain. And we want this current to be 100 microamps. Since we have 10 volts here, we're probably in the current saturation region, so let's assume that we're there. We'll need the value of K, which is I sub SDS over the pinch-off squared, 2 milli over -2 squared. That's a half a milliamp per volt squared. And here's our saturation equation. We're going to solve for the source to gate voltage. Take K, divide it into I sub D, take the square root of both sides of the equation, and then bring this on the other side of the equation as a plus V sub P. We have a desired drain current of 1 milliamp, K of 0.5 milliamps per volt squared, and a pinch-off of -2. That's going to again give us two answers, -0.586 and -3.414. But we're assuming we're in current saturation, and we have to have a source to gate voltage that's greater than pinch-off, not less than that. We can throw that answer away. See if we can solve for the resistors. So the resistor R sub S would be the voltage across it divided by the current through it. 20 volts here, and we have 10 volts here. 20 minus 10 divided by 1 milliamp would be 10K. The resistor R1, so you can find the voltage across here. It's going to be 20 volts minus this node voltage, which is equal to minus the source to gate plus the 10 volts, the drain to source voltage. The 0.586, and then plus 10. We're going to subtract that from 20, divide it by 100 microamps, and that's going to give us 9.414 volts over 100 microamps, or 94.14 K. The resistor R2, same thing. We'll find the voltage across it, divide by the current of 100 microamps. We just solved for the voltage across here. It was 9.414 minus that voltage plus 20, divided by the current would be 10.586 divided by 100 microamps. That's 105.86 K. To check that we are in current saturation, solve for the drain to gate voltage from here to here, which is going to be 0 volts minus this node voltage, but we just solve for that as 10.586. We get a negative 10.586. The source to gate is greater than pinch-off. The drain to gate is less than pinch-off, and so our assumption checks. This is a biasing of the p-channel JFET and a supplemental problem 4.9.